So batch processing, the goal, we don't have the JIPipe pipeline not only for one image, we have it for multiple images. Ideally, it runs completely automatically, and we don't have to take care of it. We start it, we run it, we go away, go lunch, go home, and then come back, and then it's done after that. This is the goal. Now, I have a little secret for you. Actually, you were technically batch processing all the time while you were working now with JIPipe. Because JIPipe has a concept called zero-cost scalability. So the nodes in JIPipe, they always process multiple data. You were just using one data item all the time, but still technically multiple ones. You might have noticed this when you were looking through results, that they always had this tabular format. And this, I want to explain a bit more how this table format actually works. Inside any input and output, there is a table. It has a set of rows, and then it has a column, a very specific column that JIPipe always has, that contains the data, the main data of this table. For example, an image, a file path, table, anything. Basically anything that JIPipe supports. And then you have metadata columns that might be there depending on what your pipeline does. In an example, we have two images, one of a duck, one of an axolotl, and each one is annotated with a text that says what kind of animal it is. And when you do batch processing, a very simple one, for example, we do auto thresholding. We give this one here to the auto thresholding node. What will it do? For single inputs, it will do a one-to-one processing. It will just go row by row. Auto threshold the axolotl, you get out this. Auto threshold the duck, we get out this. And the metadata, you have noticed, this animal, it stays. Because metadata in JIPipe is propagated across the pipeline. So the idea is you do this early. Ideally, when there are still files, then JIPipe will automatically propagate the metadata for you through the whole pipeline. And then you have it available in later steps, including exporting things. So you have the file name. You don't need to remember it. It's there. JIPipe will add it for you. So let's do some batch processing on that one. And that's why I wanted to open for you this very simple blobs example, because I need to go simple now. So we have the blobs.png as its input. Still runs, should run absolutely fine. Now we give it multiple data. And for that, we go to 05. It's called batch processing _ blobs. And there's a folder called raw, and it contains multiple blobs. And then we do the same thing as before when we dragged in one blobs. We just take all of them, all four, and then we drag them in. Then we get another file list. You see that the file list here doesn't say blobs.png or something. It just says file names, because there are multiple files now that are stored inside the parameter of this node. And then instead of the blobs.png, we are going to connect the new file list. So you can disconnect it here, and then that's it. We run it until a specific node. We run it only until find particles to D. So you can choose update cache or cache intermediate results, doesn't matter, so small data set. And then boom, we done batch processing. It processed everything. It did everything automatically, just it has multiple files at once now. And we have all the measurements as well for each single one. Now we run the convert_roy to RGB. And now it will be very interesting. And we have suddenly 16 images that come out of that. And this I have to talk about. We are confused. So the unguided iteration has some limitations. So let's analyze. So I made a diagram of that. So we gave it 4 files in the file list. The import image goes row by row in the table and then imports all 4 files. Great. The median filter processes the imported image one by one. The same with the auto threshold 2 and the find particles 2D. Now the convert_roy to RGB. This one suddenly makes 16 images. If you ever experience such weird things, we go to the input manager. This is a tab that I always skipped so far, but now it's going to be important. If I go to the convert to RGB node, if you run it, then the results will be open. We are going not to the results. We're going to one panel higher. It says inputs. You can close the documentation panel, then you have more space. And let's analyze what's going on here in this panel. Because this is very important. If you don't see anything, there might be like a message here, please click here, do this, then it will update itself. So this panel is extremely helpful because it gives you a lot of information what is happening. So it has three sections. The top section is basically an overview of your node's input. So it says here, Roy image. This is exactly what the inputs of this node are. And you see basically what JIPipe sees in the table when it's trying to resolve what is going to happen when you run it. Then you have your few settings. They are not important yet, but they will be very useful later on. And then you have a preview of these so-called iteration steps. Iteration steps are the things that JIPipe will do when you run the node. So it's basically the preview of which data matches up with which. You see here, we have 16 of those. But let's go back in the first panel. You see that we have here 4 Roy lists. These are the Roys detected by defined particle. And then 4 images that were the original images that we put in. You see here, it also highlights this with a blue color. Each Roy list is assigned to multiple iteration steps. Like this one here is to 4, 5, 6, and 7. And then each image is also assigned to multiple iteration steps. And this is what you then see later in this other panel, that you have these assignments in a different form, just so you can see what happens. So you have these Roys wrongly matched with each other. And then if you investigate this a bit, then you see, for example, this Roy here matches great, is the correct one, but then all of those, they match up wrongly. And why is that? Because you need to help JIPipe with the iteration. It needs more information for you. I give you another example where this is very common. It is the merge channels node, because it merges multiple channels, like an RGB image. And it's one that is configured with 3 input channels, C1, C2, C3. And we see this as humans. Okay, this is a axolotl. These are ducks, and of course we can match them up. But this is a computer. It doesn't see anything. Computers are super dumb. We have to give it information that it can use to discern what stuff is put together. And this is the so-called annotation guided iteration. And I've shown you already a way how to do this via annotations. So if we give JIPipe an information what kind of image this is this a duck, is this an axolotl, or your metadata from file names or any other thing, then JIPipe can use this information to match up the images correctly, and then it will do what you want. So this way, the simplest way is we use the file names. They are most unique, especially for these simple cases. For more advanced workflows, you would probably involve also the folder hierarchy names or other things. And so how can we do this? How can we add the annotation in JIPipe now? It's actually quite simple. I go back to my workflow, and then I make some space. First of all, I delete here the single one. I don't need that. And then I take here my file list, and I make some space. And we need exactly one node only. One single node. We disconnect this one here, because we will put something in between. The node is called annotate with name. Annotate with file directory name. It's the simplest node to use for such cases. And then we just put it in between. Don't forget to connect it correctly up. The file list goes into this purple node, and this purple node then goes into the input image. There is no direct connection between file names and import image. Really, really important. So let's show what happens. So these are the file names. when I run the file list node. If I run this one here, you see that it also contains still the files, but the annotations are now added as an additional column. By default, it will make a column called hash dataset. This hash is important. I will explain about this a bit later. And that's it. You can go, for example, here to our image. It's still there, the dataset. As I mentioned, these annotations, they propagate through your pipeline. And then let's check now the input manager of our converter to RGB. What is going on there? Inputs. And then here for me, it also complains you click just this button or click this update predecessor cache, does the same thing. You wait a few seconds and then boom. Now it looks a bit different compared to before. We have the iteration step assigned uniquely. This row list is uniquely assigned to iteration step 1. And you see here the highlighted dataset column in green because JIPipe tells us it will use this column from the annotations to discern the data. And then our iteration steps are absolutely matching up. So when you check here, they're also nicely colored now. They are colored exactly as is in this input panel, so you can visually match them up. And then again, the annotations propagated through the pipeline. This works now. Let's run it. Update cache. Boom. We have everything. We have the images. They are visualized. And they are also even annotated, so the metadata is still there. And then this is why this viewer is then extremely useful, because imagine you have some data that you are viewing in this image viewer. You always have here on the left side a panel that says annotations. There it is. You know immediately which one you are looking at. It's blobs 1, blobs 2, blobs 3, blobs 0. And this is the basic iteration, how you can do it in JIPipe. You just annotate the data, ideally early, and then it will do automated matching for you. And by default, and it's important to know, it will use these annotation columns that are prefixed with a hash. So it's a bit mouthful of a name. Use columns prefixed with hash. Union default, so it's basically the default setting. And it basically tells JIPipe, okay, use the hash columns for identifying which data belongs together, the others ignore. And this way you can add, for example, information that JIPipe should not use directly. For example, you can grab information from these OME data that is stored inside these native microscopy formats. Add it in there, add pixel sizes, add other information.